Here we have the HM21 test unit and the hand applied probe. When the probe is correctly positioned in the hand applied probe, the needle should be in line with the two outer screws. At the back of the hand applied probe is a switch. This is an interlock switch to prevent flow of current. At the bottom position, it's in S, which is for short. That means the current can't flow through the probe and into the sample. This is useful because if you have current flowing when you introduce the probe to a sample, there can be micro arcing. This could substantially reduce the lifetime of your probe head. Once the hand applied probe is in position on a sample, you can flick the switch to R for read to make a measurement. Once the measurements are completed, switch the probe back to S, and you can then remove it and introduce a new sample, or introduce the probe to a different area of the same sample. When making a measurement, the hand applied probe should be introduced to the sample by rocking it about the rear axis, down and onto the sample. You can check the contact point of the needles by looking at the front of the unit where there's a cutaway to see where the needles contact the sample. I'll switch the switch to R so that we can make a measurement. And the HM21 here is on 10 milliamps, which is its highest current. We needed 100 milliamps really with the RM3000 Plus. So instead of getting 3 millivolts, we'll expect around 0.3 millivolts. So we're coming down towards the limits of measurement of the HM21. I'll pass the current in the forward direction. Then we're getting 0.304 millivolts. In the reverse direction, we're getting 0.291. Maybe they could match more closely. So we need to zero the unit. While the current is flowing, press and hold standby until it says zeroing. So once the unit's zeroed, we've now got 0.299 in one direction and 0.300 in the other direction. These are extremely close matches and a good result. We can press ohms per square, and that will tell us that we're around 135 milliohms per square. It's the same result as given by the RM3000 Plus. Always remember to stop the current flowing and to switch the switch at the back of the hand applied probe before changing to a different sample. Here we have the second similar sample. We'll switch it back to read, and once again we'll run the current. We've got 0.297. In the reverse direction, 0.298. We've already zeroed, so that's why they're so close. In ohms per square, we've got 134.9 ohms per square. I'll switch off the hand applied again, and now we're back to the bigger sample, which was a little more conductive, maybe more difficult to measure. With 10 milliamps, we're getting 0.126, and in the reverse direction, 0.129, 128. So these are good, and in ohms per square, we're getting 58.5 or so ohms per square. We're making very small measurements, so the unit will fluctuate slightly, but those kind of measurements, especially for very conductive items, are extremely good and represent the true value of the samples being measured.